Okay. So I again welcome all the participants to this short-term training program, which is AICT and AQIS approved on image processing and its applications. So I welcome you all again, and I welcome also respected Praveen sir for the session. And we have this session on the topic of the implementation of face aging and face alteration using deep generative models. So I welcome all the participants for the session. We can start now, sir.
Thank you, ma'am. We left here. This one have a generator and this one have a discriminator. Deep convolution generative adversarial network. This model is the stabilize the generative adversarial model training mechanism, because initial when GAN is introduced, have a major problem is related to mode collapse, and then mode collapse is a major problem. This problem is overcome by this deep convolution. How they were overcome? They were removed the pooling concept used for straight convolution in discriminator and fractional straight convolution in generator, and they were used the batch normalization concept in generator and discriminator, and then ReLU activation function in all layer except the output layer, which use the 10, means output layer have a 10H layer, and then leaky ReLU activation in the discriminator. This 4 parameter is major related to generator and discriminator things. All these 4 points I have implemented in Collab. So we start for the implementation of DC GAN on MNIST dataset. First we mount it, then same we create the input directory and output directory, similar to previous autoencoder concept. Then all the packages I have implemented for torch. The image size is initial MNIST data side have a 28, but I have resized it because this code is common for celebrity data set also. Then your generator input, the generator input is 100. This time the generator input 100 meaning is this one is this one, this noise, this is the prior noise. This one is prior noise because I link all this code to this mathematical equation. This is the prior noise. Then output dimension have a channel is 1 because we have a grayscale image. This is 1 mention. Then the number of filter map for indiscriminator, the filter map is this way. 124 to 512, 256, 158, and then in the case of gray have a 1 and the RGB have a 3. This 228. Then the learning rate, then this was parameter from Adam optimizer. Base size is 128 because the grayscale images. This reason go for the 128. Then epoch is 10. This on the data loader. MNIST is available in build dataset. You're not required to download it. MNIST dataset, this function is automatically download from net and then store in particular location. This normalization concept same resize because initial size of dataset is 28 cross 28, but our requirement size is 64 cross 64. To resize it, image size, tensor, then normalization. This is a very important concept. In my previous script, I have used the 3 value here because this related to RGB, but this time this is related to grayscale. So go for 0.5 and 0.5. Next program, you go for the celebrity data set, you mention the 0.5, 0.5, 0.5, 3 times mean and standard deviation value. This is the major difference between grayscale and RGB image purpose. Then this one have a generator architecture. So first I have a show to diagram. What is the generator? This one have a generator. Means convert noise to image. Means perform the upsampling operation. Means a deconvolution operation is performed. First, this same function, generator have a class, init method, like have your constructor concept, forward method. This hidden means input is noise and X hidden layer. This one hidden automatically called. This one hidden. Sequential means sequential model used to combining the multiple layers in single. First I0 initial. When input is 0, first convolution, this con transpose function used for upsampling purpose. In my previous program, I have used the upsampling 2, but this time I'm using the con transpose 2 function. You can try also upsampling 2, maybe get this result better to you. Input dimension, number of filter. The first I value is 0. The filter is this way. I have make the array 1024, 512. The first feature map is this one, the input feature map, this output kernel size the 4, stride is 1, padding is 0. This one the first feature. When I value is except 0, then this one is running, means for previous input is 1024, next input is 512, then for next is input is 512, then 250. This way the deconvolution layer is created, but in between, according to DC Gyan paper, have a batch normalization concept and ReLU layer you can use it. So this one is add. Then next one is initialization, batch normalization. This one have a batch normalization. In hidden layer, we add the batch normalization to concept is used. But in our autoencoder concept, we not use this concept. So we use for one more layer, the name of this layer, the batch normalization. Then after have a ReLU layer. So this one is the first rule related to replace the pooling layer with stride convolution or deconvolution in generator. It's frictional stride convolution. Batch norm we use, and then ReLU activation use in generator. This one have our generator architecture is. Then call this one have a loop running on number of feature length. Have this one the 4 feature I have used 1024, 512, 256, and 128. This type 4 time running, and this generator is prepared. So this one have a generator architecture, but upsampling it. The input is Z. The next one is the discriminator. In the case of discriminator, according to this diagram, our discriminator have a reduced the size, means input image, output of generator it convert into as a classification in sigmoid form, 0 or 1, means real or fake. How we can do this thing with help of discriminator. So discriminator is convolution. Convolution means in the case of convolution transform we increase, then convolution 2 means we decrease. Convolution is performed in first layer. This is a number of feature 1024, kernel size is 4, stride is 2, padding is 1. In first 0 layer, the next one have this layer 1 is, then same features. The first one is then this one in 3 cases. Then go for norm. This one the weight initialization purpose, batch norm and discriminator also. Then we have a leaky ReLU. This one have a leaky ReLU activation in discriminator all the layer. This is the standard protocol related to DC Gyan. Then this one have a leaky or 0.2 function. Then or add this all layer. Then last layer is the 10H function. Sorry, a sigmoid function. This one is the sigmoid. Why we use the sigmoid? Because discriminator work as a classifier, means give 1 and 0. 1 for your real image and 0 for your fake image purpose, or the sigmoid range is 0 to 1. This is in the last layer of your discriminator is sigmoid function. So this hidden layer and then output layer. So this one the generator architecture. Generator take input is a noise, and then the discriminator is take output of generator, means this one the proper image size. Then what is the output of discriminator? Either 0 or 1 value. This way create the discriminator and generator architecture. This used for plot purpose. This time I'm not explaining this. I'm explaining these things. Generator, input noise means 100. Number of filters means they all have a filters. This one is 100 is the size. Features. Output dimension of your suppose base size is 128. 128. Then 64 cross 64 size. The first generator is called. Then this one is generator. This one have an input. This all the layers deconvolution is performed. Then I'm showing also this thing. This one have a your generator. 100 is input. 1024 is the channel feature map filter. Then have a batch normalization in ReLU. In our previous we not have a batch normalization. Then con transpose, this one have a con transpose batch norm. All this have a upsampling related layers. Then have a this one have a discriminator. 128 kernel size, stride, padding. Then feature map is this way. Okay, this one have a then here is the leaky ReLU is used, and then in generator side we use the ReLU function use. Batch normalization in both the side. The last layer of your discriminator is sigmoid function. This one the architecture related things. Then next go for the loss functions. This have our loss function is this one have a discriminator loss function for log inverse, and then log probability for real images, because discriminator train on real images and fake images both, and your generator is only trained on the fake images. The same, this equation 9 and 10 I have implemented in this code. To explain how I can implement. This one have a generator output, then this one have a discriminator. Then all this in binary cross entropy, BC binary cross. This one optimizer. This one the grids, the size of your input. Then this one have a Y label starting for the loss functions. Because have a discriminator have a two value, 1 and 0. So this one have a representation of 1, batch size. Torch 1 have a real data purpose. Torch 0 for your fake data, because 1 indicating your real data and then fake indicating your 0 purpose. This one have a create. This have a 120, means one hot vector type creation. What is the input of discriminator? The real data is the input of discriminator. So this X have input your image data, pass into discriminator. The switch is removing the single dimension entries from the shape of array. This is the real decision. What is the decision? 1 and 0. Because what is the output of discriminator? Have a sigmoid function. Sigmoid is give the 1 and 0. And then this one is real and fake. So first we train this, first we calculate this discriminator loss on real image. Discriminator loss function on real. So what is the criteria? This criteria function have a binary cross entropy. This one have a criteria. Binary cross entropy. This one the binary cross entropy. Binary cross entropy. This one have a your discriminator function. The same. This used for real image purpose and this used for fake image purpose. First one is this one. This real loss calculate. The real label and then cross entropy between the result generated by the discriminator, this loss. Then discriminator train on, first train on real data, this one the training on real data. The next discriminator train on fake data also. So we have this fake data is generated, random generation. This one dimension is adherent, the random generation. This is the dimension. Batch is 128. 100 is the dimension of normal prior distribution or have a vector, nor random generation vector 1. This pass into G, because Z is passed to generator. This one the generated image means the fake image or generated image, the same pronunciation. Then this generated image is passed to discriminator. This one have a discriminator. So this line is related to real image loss function calculation, or this function is related to your discriminator on generated image. But who generate the generated image? Discriminator is generated. So first this line is generated by the generator. Then the generated output is passed to discriminator as input. Then this one again 0 and 1 form. Then this compare the fake labels. Fake label have a 0, 1. Then this loss is this defake loss is related to your discriminator on fake images, means invertible log function. Or this one have a D real loss on simple log function on real images. The combined loss function is the discriminator loss function. This is the D loss. This one is discriminator. Then back propagation gradients for back propagation purpose. Then the next we need to train our discriminator. So this loss function I have covered it. This equation number 3. This first terminology is related to real. Then second part is related to your fake images. This thing in this code. These two loss functions. Then after this, we require to train our generator. The generator input is the random noise. This one a random noise, convert into CUDA, then pass to generator. This generator. Then generator, generated image again pass to discriminator to classify this image is generated or this image is fake. So criteria loss, this one real and fake. Then criteria, this one have a G loss. So 3 loss in discriminator. First 2 loss related to your discriminator, the D real and D fake. this related to discriminator. And then third loss is generator loss on fake images. Then this one have a generated this way of back propagated it. All the value I have a save in the form of to creation the graph. Then this plot to create the grid output for shape formation. This way our program is running this way. This one have a loss function. This one by one time discriminator, one time generator. Then next discriminator, generator, till when this generator is try to approximate the real data, means those data generated by generator is same as to real data. Then this stabilized situation means this one have a stabilized situation, means generated data equal to real data. This one implicitly, this one have architecture of generator and discriminator. This 4 parameter I have incorporated in this code. Then this one have a I have mentioned the wrong label. This one MNIST data set results on 20 POC. This one have a competition between discriminator and generation. Discriminator loss in your blue and generator in orange type color is both the network is competing to each other. Then same code you can run on celebrity data set, DCYAN implementation. This celebrity data set is publicly available data set. In this celebrity data set, this data set is widely used for face alteration purpose, because in this have a 40 attributes that were mentioned, like have a different type of hairs, female, males, then mustache or not mustache, age available, bald hairs, different type of hairs related category they were mentioned. It means global and local attribute mentioned in this celebrity data set. The epoch 1 generation, very blurry image generated, and this result is stabilized. This data set in wild data set, the two type of data set generally present in wild or have a supervised, means in wild means this data collected with help of the net, means not of pose invariant, occlusion face. Occlusion means where the capes of face is your height. Then this type of data set generation result is this one. Then this a competition between generator and discriminator, G and D. You implement this on same program you implement on celebrity data set. This is publicly available, you can download it, but if you run this program minimum 20 hours to get these results, or you require a lot of resources to run this program. Any doubt till this generator related things? This generator and discriminator, I have run this code. This code is running. This way is design the generator, and then this one have a discriminator. Same. So if you design your network, try to apply some concept in this generator and discriminator. Maybe use your algorithm. You change the filter size, use the data size, change the kernel size, and draw the graph. Which then you can find out which one is stable. This code I have taken from GitHub. This one is openly available. You can also take and use it. The next one is celebrity dataset. Then the application of this generative adversarial network. In generative adversarial main have a two components, generator and discriminator. In autoencoder have a two component, encoder and decoder. Then this one the different variant of generative, approximately 100 variant available in research area. This generative, initial generative, then CGAN means condition. If you require to modify your latent vector, then conditional generative adversarial network is used. This C, you add this means alter your latent vector. Then AC auxiliary YAN. This auxiliary YAN is the output of discriminator, means classification purpose. You can also use your discriminator. Then InfoGAN. This one is used for maximization purpose of your information. This variant, different variant. I only show the how to club discriminator, generator, encoder, and decoder architecture. This one the different combinations of encoder decoder architecture. Same concept, with help of the same concept, I have developed the one model. The name of this model is conditional perceptual adversarial variational autoencoder. This model I have developed in 2019. This model have a combination of three generative models. The first one is two generative models, VI variational autoencoder. Then the second one is generative autoencoder. In my first session, I have designed this autoencoder. Same autoencoder I have a design, but not using the sampling. Sampling thing I have using the gender alteration. So I have take this sampling concept and use this sampling concept in encoder. Same feature is feature map, input size, filter, all the things is same. Then Z is generated. In my autoencoder concept, I not add the any condition. This time I use the L. L is conditional vector. This one the age vector. So this model generate this one the input to predict age progression, means face aging. Generate the future image of your. Suppose I have a 10-year, then I want to generate the 20-year image of my. So with help of this model, you can generate it. This concept known is the face aging. Then the reverse concept is face rejuvenation. Means 20-year people convert into 5-year people. This thing is also possible with help of this conditional vector. This on the one hot vector. This one hot vector have a two major information I give as an input. First have a age label. Then second one age of student or age of a human being. Face data set age label of input, and then gender means male or female to this L. Then this latent vector I have passed to this decoder. Or in the case of generative adversarial network, we use decoder as a generator. So we use this as a generator concept, means this J pass into this. Then here I have not, in previous my program I have used the L1 and L2 loss, but I have a use for better result. I have used the perceptual loss. Perceptual loss I have used for VGG19 layer to extract the features from pre-trained models. This pre-trained model is trained on ImageNet dataset. I have used the weight of this model and extracted the features from different layers. I have also showed the result, which layer give the which results. I have used the two combination. The first three one is the VGG 1, 2, 3, and the last three one is means 3, 4, 5. The two combination I have used in my paper. The first one VGG 1, 2, 3 is pre-trained layer of VGG. First three layers, and then last three layers is 3, 4, 5. My loss is not MSC, not L1, but the perceptual loss. Perceptual loss is related to pre-trained models. We extract the features from pre-trained model. Then this way I have a result. Then two discriminator. This one an encoder. Then two discriminator. DZ. This DZ is used to regularize this Z, means how to make the Z is better. Then this discriminator to generate the image very plausible, means synthetic image generation is very plausible way we generate it. Have all the eyes formation, nose formation, mouth formation is proper way. Then this one have a my discriminator. This same in the case of this convolution encoder have a same discriminator, convolution, convert 2, 3, and then fully connected layer. Then to this discriminator have a fully connected layer base. I all mentioned the notation. This one the input related, convolution, ReLU, linear. This have a linear layer base. Then this one have a convolution layer base. This model is the name conditional. Perceptual means this perceptual network. Adversarial, because the two adversarial loss I have a use. The first adversarial loss between encoder E and the discriminator DZ, and then second adversarial loss function I have a use between generator and the discriminator D image, and then third loss I have a use the perceptual loss I have used, and then KL divergence use for sampling purpose I have used the KL loss. This one I have use the manifold learning to first convert your image to lower dimension, means convert 3D image to one dimension. This is the manifold learning concept, and then again generate this lower dimension to high dimension with help of the encoder. In my network have a 4 component is present: encoder, generator, and then two discriminator. One discriminator to regularize Z, means latent vector, and then one discriminator D image to generate the more realistic images. The input size is my 128 cross 128. Then I have used the color images, the 3. Then apply stride convolution, all the thing I explained is the input of encoder is X, means this one the input. Then what is the output of this encoder is the Z, latent vector. Then output or encoder is added with condition. This condition is added with Z is the latent data, condition is L, and then this input to generator. Then condition age vector sent to the generator. Then DZ regularize the uniform distance smoothing the age transformation. Then D image to generate the realistic image transfer. These 4 major components. Those things I have covered in my previous slide. In this I have club all the things. This have a 4 loss function. First, this have a loss function between. This loss function is related to the encoder and the discriminator dz. This one have a loss function between dz and encoder. Then second loss function is related to this generator, and then this d image, discriminator d image. This one have a loss function is this one adversarial loss. This loss function as it is same as this loss function. Only I have incorporated the sampling concept. This in the loss function. Here the sampling is not present. I have introduced the sampling concept in this. This one increase. This one is improve the my result, quality or quantity results also. This one have a sampling concept. The same. Then next one, perceptual loss. In my previous autoencoder based concept, I have used the MSE, but here perceptual. This is the extracted the feature from pre-trained model, or the I am using the VGG19 as the pre-trained model. Extract the features for pre-trained, then weighted sum, then KL divergent loss. So I have used the 4 losses: 2 adversarial loss, 1 perceptual loss, and then 1 KL divergent. This all loss have I combined it. First one have a first loss is adversarial loss, second adversarial loss, KL loss, and then perceptual loss. This lambda 1, lambda 2 is the hyperparameter. I have this explain all the things in my paper very properly. Then this one the initial input. This one have a initial. I have trained this model on morph data set. Then this one have a age prograde related results. This one you see that the changing in the faces. Some here the mustache is not proper. Here mustache is very light. Here the mustache is properly formed. In our previous result, the eyes node is not properly visible in this, but eyes and nodes is very properly visible. In face, like in this autoencoder concept. See that eyes is not properly formed. Means local and global feature not properly generated, but with help of this model, I have able to generate all the features is very proper way with agings. This way, eyes is properly formed. Then reconstruction, wrinkles also forming in early age. The wrinkles is not present in this last row. The wrinkles are present because in about 40-50 years the wrinkles is present. This our first category is 20, below 20. Then next one is 30 to 40, then 50 to 60, then 60 to 70, and then last one is remaining images. So this one have our result generated by our models. Then I have also trained, I have developed the one data set, the child longitudinal face data set. This one I have trained this model on this child. This is only 10,000 images I have developed it. This input, this 13-year input, then generated result in 0 to 5 year. Eyes is very properly formation, mouth is very properly formation. Then 6 to 10 year, 11 to 15 year, 16 to the 4 category I have a generate. Means this input, that this on the future look of this image, this is the age progression, face aging. Input here the mustache is not here input image. Then in first 0 to 5 year mustache is not present, but in last 16 to 10 year the mustache is properly formation. Then this year same. So that then girls is also means identity I also preserve, means girls look like girls, means not make the boys, because the main challenges in related to face aging, gender related issues. I have resolved this issue with the help of latent vector, this age progressions. Then this result is VGG 1 to 3 layer. Initial layer I've used because initial VGG layer have stored the low level features. So this low level feature is give good result in my models. But when we use the higher layer, so have you see that the very distorted face is generated, means the mouth is not proper formation, eye is not proper, lips is not properly generated. So this one have a VGG 3, 4, 5 results, or this one have a VGG 1, 2, 3 result. So your pre-trained model initial layer store the low level features of face, and then the last layer high level feature information is stored. Some model high level feature is very useful, but in my model, the high level features is disturb my result. This is then I use the low level features. These are face aging results. Any doubt in this? Hello? Hello, any doubt in this model, how to loss function is working? Because this is the extended part of generate encoder, decoder, and DC GAN. I have club, encoder, and DC Gyan and designed the one model. This name is perceptual adversarial loss. And then for more detail how this loss function is working, you read this paper properly. Then I have explained all each and every term in this paper. I have mentioned this paper. This one is paper. Then this one is one more my new model. On this coming 16, I have a presentation on this model. This model I have a published in B-level conference. This model have a generated only child-specific model for to trace the missing children's. This one have a my encoder. This one have a generator architecture. In my previous model, I have a convert into latent vector formation, but in this, I have not generated the latent vector formation like that. This one have a latent vector. I have not generated the compact representation. I have only I have stopped my model on 8 cross 8 cross, then again generate it. This one have a my new model. This one have a residual block concept. This a con1, con2, same 32 have a feature. Filter size in my previous model I have used the 4, but this time I have using the 7. Stride have a 1. Then go for next one is next convolution 64. Then 128. Then residual means skip connection I have used to shift low level feature to next layers. Then again deconvolution. Here the latent vector is not present. I have only this architecture is related to image translation network. Then generated. Then this image I have a pass to my in my previous model I have used the one discriminator, but I have used the multiple discriminator, 2 discriminators. This is the page discriminator. In the case of page discriminator, my output is not sigmoid layer, my output is patch format. In the case of previous discriminator, I have used the 0, 1, means only one vector size, but in my discriminator I have used the 4 cross 4 type of pitch. And then second discriminator is this one. So 2 discriminator I have also used in this. Then the 2 loss function I have used the H classifier. Also use this H classifier. I have a train on my data set. This data set I developed in my lab. H classifier, for H classifier purpose I will use the light CNN. This is a very lightweight model. I have trained my data set, and then VGG loss I have same use, but I have not used the last layers of initial. I have only used the first layers of VGG, get the better results. Then input size is same. Then this 2 discriminator, this one the perceptual law. This I'll have an explanation of this diagram. This one have a comparative study between my model and existing state-of-art models. This one my youngest face, same face, 15 year means this 10-year student face. This one have a 15-year student face. Same subject 1, youngest and oldest face. I pass into my model, age progress. You see that the model is giving this child face is my model name. Then CPV is also my model. I have developed the 2 model in face aging area. CPA conditional perceptual. What is the problem of this CPV? Beautification on faces. You see that on the second row, face is beautified. The eyes and nose is very properly formation, but skin color is not preserved. In my model, in present model, I have preserved the skin color also. Child face, this is the name of my model. Then age is, this one have a 2 to 5 year old children, then 6 to 8 year, then 9 to 10 year, then 12 to 16 year, then 15 to 16 year. You see that this one have a 2 to 5 year. This one a proper aging is performed. Some distortion is available. I am working on this and remove this distortion in coming paper also. This one have a young image as an input and progress it. Young to old. This one is old to young, means regression. So my model have both the capability. My model are able to progress the result and regress the result, means younger to older and older to younger. This one have a, then this result on also. My model is also preserve the identity. Identity means girls like the girls, means not convert to boys. So in this model like AIM, in this model have a similar type of face they were generated, is identity is not, they were properly preserved. Skin color is not properly in use that like that. and subject. This is result in age. I also form the goggles is also coming. So glasses is also coming in the higher age group in bottom. This one is quality comparison. IPC Gyan is the published in CVPR paper. We try to compete this paper for qualitative purpose. We compete it. This model. This is the result generation of our model. The main what is the challenges of this? Required to provide the recognition on this model and verification, identification on. I am working on this. In coming paper, I will resolve all this issue. This I have my paper. I have published the 4 papers. This one have my ICB paper. This best awarded paper. Then last this in this 16th of September, I have present this paper in this conference in Germany. This all references I have used it. And one more student have asking how to calculate the parameters in models. So I have explained this thing. Because initial the people asking that what is the parameter in models, what is the fully connected billions of parameter, how you can calculate. I have also explained learnable parameter in CNN. This thing I have explained in morning. Then first one is how to calculate the parameters in my model. Number of parameter is present, means floating point related things is present. Based on this, you decide the GPO is required. I have explained with help of one example. If you have a pen and pencil, please try to solve out this example. Then you can find out what is the number of parameter in my model and what is the number of parameter if I develop this model, or how do I reduce, which layer I have emphasizes. This with help of this topic you can find out this number of parameter. This one the formula, and this one have your input layer. This one the output layer. This is the convolution 1 and convolution 2. L and M is the filter size. N is related to your and M filter size. L is the input feature map of input, like 32 in this example. K is the feature map of output. The number of parameter in this convolution layer. The number of parameter is N, and M means the filter size. Like in my autoencoder, I have a 4x4. In my CPVE model, I have a 7x7. Then gender and alteration purpose, I have used this 5x5. So filter size is here 3x3, and the input means previous layer feature map. Here is the 32. This 32. So multiply this plus 1. 1 is related to bias. Then output feature map is K. With help of this, you can calculate the number of parameter in your convolution layer. This is the standard formula to calculation the convolution. Then pooling layer never be used to learning parameters. Then highest parameter in fully connected layer. The fully connected parameter N plus 1 plus M. N is the number of input, M is the output, and then output layer a formula is similar to fully connected layer. I have one example. This one my input size 5 is the filter, then convol, then pooling, then convol, pooling, hidden. Then parameter I have a calculate is first input is this one have a size, input have a not parameter. Then convolution 1. Convolution 1 is stride is 1, 28 is my size. Then filter have a 5 is my filter size. This one have my 5 is the filter size. Then minus 1. This one 24. Then what is the size? This one the output size. Then formula to calculate the number of parameter N or M. N or M is related to your filter. So 5x5. Then L means have a grayscale image. So grayscale image input is 1 plus 1 for bias, and then K for your output feature. Output feature is 32. The first convolution I have required to 832 parameter. In this layer, I have number of parameters required 22. Then next pooling. Pooling never be learned. The parameter means weight and bias concept is not present in pooling layer. So parameter is 0. Then second convolution. After pooling, we have a size is this. So 12. The filter size is second layer. I have a filter is 3. 3 convolution is my filter. Then go this way. N plus N into M plus 1. This is the formula. 3. The input. Filter N into N. 3 is the filter size. Then 32 is the input. This one is input. Then plus bias. 32 is output. This one have a parameter. Then max pooling have a no parameter. Then fully connected layer, this one have a 256. I have a 256 is the feature size. Fully connected layer size is the final layer have a number of node is 256. For fully connected layer purpose, the calculation is s plus 1 into m. N is, this one is input feature is 32. Then filter size is 5 cross 5. This one have 5 cross 5 plus 1. Then output is 256. So in convolution, if you compare convolution and fully connected layer, the number of parameter is very higher in fully connected layer. So this reason at the time of generative adversarial network model is developed, this one having a very Vanishing gradient mod collapse problem. They were resolved with help of the convolution layer. They remove the polling concept. This is the main reason. Then output layer. This one the total parameter in LexNet 5. This one have a this way you can calculate the parameter of your model. Same concept you can apply on this. With help of this, you can calculate the number of parameter. The convolution one, your filter, your inputs have a 3. So your input, the formula is simple, n into n. L is input plus 1, then output features. And n in the case of have a 4 cross 4 plus L for input have a 3, then plus 1 for your bias, then K output have a 64. So this first convolution parameter you can calculate it. Then second convolution parameter is the filter size is same 4 into 4, then but the input feature is 64 plus 1 for bias, then output is 128. This way. Then this one have a parameter of convolution second. Then third convolution, and third convolution same, but have this 128. Then this one is 256. Then next one, same convolution 4, have a 256. Filter is 4 cross 4 1. Then have a 5 1 2. So this way you can calculate your parameter size. Okay. So this one is my model. Any question? Hello? Hello, any question related to this model and how to develop and how to start the research on generative adversarial network? Because I give to 1 hour or half an hour, so you can ask the questions. In this type of challenges, if you face, to start developing the generative adversarial network models.
Do we have any questions? They are in chat box.
CNN can be used moving object detection. Santosh sir explained moving object tracking. Definitely, generative adversarial network is also generative adversarial network applicable for every area. In related to deep learning, if you want to work on medical imaging, generative is applicable. If you want to convert on text sentimental analysis, generative adversarial is present. If you want to work on face related anything, then generative adversarial network are working. If you want to work on VD, 3D related, morphing related things is, pose invariant related things is, everything is applicable with generative adversarial network. This is the most powerful network, is developed by Yoshua Bengio, and Yoshua Bengio is the father of deep learning, who developed this generative address. The student of Yoshua Bengio is developed. The name of student is Ian Godfellow. After 2015, every good conference and general paper, 10 out of 6 paper based on generative adversarial network. The top conference is CVPR. From 10, 8 to 9 paper based on generative adversarial network. How to design your architecture? This is only plug and play. You read paper, then club all this thing, then run this thing and try to implement, modify your code. This is only way you can learn these concepts. Image enhancement used for percept, like image enhancement purpose, I have used this model. You see that in my diagram, I have using the image enhancement also. Here this image is very low resolution, but this will have high resolution, means beautification on your faces. For beautification of your faces, you use the conditional generative addressing network with perceptual loss. Perceptual loss is mandatory for the super resolution purpose. Means image enhancement. Image enhancement come in the category of super resolution purpose. So use the pre-trained model. Pre-trained means this model is already trained on billions of data set. You not require, this is not possible for our, we can purchase a lot of GPU and train on billions of images. We use this pre-trained weight and then extract the features from this model, and then we use in our model. This one is possible using perceptual loss and conditional generative adversarial network. You can use and DC GAN modify architecture. Your topic is related to super resolution. Difference between CNN and generative, which prefer real-time object detection. Both have you can use both CNN and generative adversarial network. You can use in object detection, but generative adversarial network is very give very plausible result compared than CNN, because if you go related research, CNN is almost saturated. Almost people working in generation and then go for the reinforcement learning. You can use the CNN and gain both on your object detection. Any question? Okay, I have a ma'am. Any question? Otherwise, I will explain how you can start the research.
Sir, we can continue, sir.
My slide presentation is over, ma'am. I give to guide how you start, because inside I have mentioned which model. If you want to work on generative model, you take this code from GitHub. All the code is available on GitHub. You try to develop this code and each and every loss function you discuss, then read paper, then start working. So what is the sequence I am explaining? If you have not any question, this code I have uploaded in GitHub. This code is available on GitHub. Validation image analysis technique for aging images. Validation image. I have explained these 4 models. Validation or verification. Your question is related to validation or verifications. Means state of art model. The state of art model is this. The 3 state of art model. IPC GAN, Identity Preservation Condition Generative Addressing Network. And then one more is CAE. CAE is related to conditional adversarial autoencoder. Then lot of model is available. This IPC GAN and CPV is widely used. If you develop this model related to aging, you must be compare your model with IPC GAN and then CAE model. This is the state of art model in, because both paper, this model is published in CVPR paper, CVPR the A* conference. If you want to start research, please read the CVPR paper or ECCV, WCV paper. If you read, then you get a lot of idea from these papers. What is the model architecture they ever use it, and they try to implement this model architecture in your GPUs. Paper reading is the key thing to in research. Yes, ma'am. If you start working, my sincere suggestion, if you start working on generative addressing network, first go this slide. This slide is very important. First, this one. This is the sequence to move on generative addressing network. First, you develop the autoencoder concept on MNIST dataset. Then go for the variational autoencoder concept. Then go for generative addressing network concept. Then go for conditional. Then go for adversarial. Then go for the DC GAN. This is the sequence. All the code is available on GitHub. You read it, you read the papers, and then find out which thing I have incorporate in my models, then run it. This is the only way to develop the models in deep learning area or work with team. This is the one. Second, you discuss this model with your colleague and then find out this model take time. This is not easy task taking the code and start running your code and your result is come then publish paper. This take time, lot of take minimum 5 to 6 months take time to develop the one model. Anything, otherwise we can stop this session.
Okay, so do we have any questions now?
Or if you need implementation related queries, then I show implementation things.
Sir, how we evaluate GANs and like
Oh,
when should
yeah,
we?
matrix. I've explained this matrix. The first, for image quality assessment. Quality assessment means image generated is proper. Not a two score is used. First is inception score. This inception score is based on your inception V1 and V2. Inception V1. This one very popular network designed by Google. Inception V2. This one is the inception score you can calculate based on this model IS inception score. First matrix, then second matrix is FID. This one the score. This one is also based on inception model. One is intra-class or one intra-class variability is calculate. FID is calculate for image quality purpose. Means my image generation is good or not. This thing you can calculate the inception and FID score. Then second thing, for face verification or face identification purpose, you use the state-of-art model. The two state-of-art model is FaceNet. This one developed by the Google. The code is available on GitHub. And second state-of-art model is ArcFace. This one is developed by the researcher. I'm not know the exact name. This two model is the state-of-art measure for face verification and face identification purpose. The face verifications and identification, one-to-one or many-to-one matching purpose, use these two face matchers you can use it. This face matcher is designed with help of TensorFlow, and then but the PyTorch version is also available on GitHub. Or this they will use the two data set is VGG face 2, and then second data set is Cassia face data set. This all data set is available on public domain. ArcFace is trained on IMDb. In the initial I have mentioned this is the largest data publicly available data set, IMDb, Wikipedia data set. Then this data set, and they will use the VGG face and Cassia face. These two things, you face verification and identification, you can use this thing. Then this inception score, FID, face verification and face identification. And then I show the one app is Face++. This is the Chinese app. With the help of this app, you can estimate the age, you can estimate the gender, you can also verification, identifications, then the beautification score, all the things, means face related things. If you want to evaluate your face, then go for the Face++. This Face++ is openly available, but the main problem, you require to upload each and every image one by one. So this have a main, please note down, this is the very important inception FID, face verification purpose, FaceNet and ArcFace. And then for Face++, you can use everything, means beautification, verification, and identification purpose. Any question?
Yes, do we have any questions? Sir, you told there are various types of GAN you have explained.
Yeah.
So what in what particular area we can apply?
Every variant is used in every area. How you can use this is depend on you, because this is not fixed. This is like this. I only mentioned the 4 variant of generative adversarial network. This is the widely used. This CGAN is most important one. CGAN means how to incorporate the condition with latent vector. This condition may be at generator side, this condition may be after generator result, or this condition is maybe at discriminator side. This CGAN, the lot of variant available in CGAN, lot of architecture variant is available in papers, CGAN papers. Then auxiliary means if you want to use your discriminator as a classifier, to use the auxiliary classifier, means discriminator give the real and fake 0, 1. Use the cross entropy loss in the last layer of discriminator, then your discriminator use as a classifier. Generally use for classification, we use the softmax at the last layer of your CNN. same concept you can apply on discriminator. To your discriminator have a both capability. Also give the real and fake, and also classify this generated images belong to this category, or this generated images belong to particular this attribute. So this thing is also possible with auxiliary GAN. This C-GAN is most powerful. Widely used, every model based on generative must be used the C-GAN concept. This have an info GAN, a mutual exclusive based concept. They were using it. If you have any doubt in perceptual loss, because those who want to work on super resolution images, how to increase this, how to 16x16 low resolution image to convert into better size, means resize it, or this, when we resize it, that all the features is present. This thing is possible with help of the perceptual loss.
Sir, can we apply this GAN rather than image data, like on text?
Audio, video, text, everywhere is GAN. In comments, text to image, text to image, image to video. This is generative adversarial network. Like you hear the deepfake is fully based on the generative adversarial network concept. Mismorphing, then synthetic, your image is also synthesized. You are, suppose I have my fingerprint data set is available, I want to generate the fingerprint also, means your minutia thing is related. With help of generative models you can generate it also. Means your palm print you want to generate it, this is also possible. Means synthetic image generation, means data is not present you, but you want to generate it, the generative model is applicable everywhere. Then one more, this time one more current protocol, adversarial attack on your image. How do we misguide the my classifier? So I have a Praveen, but I have changed the my eye. My eye have a black. I have changed this eye color, then misclassify my matcher, means like have a biometric related attack. This thing is also problem. This used for security purpose also. So this one adversarial attack. This the name of this topic is adversarial attack. Use super resolution purpose, adversarial attack purpose, 3D related things, video related things, then haze remove purpose. Haze means remove the hazy form haze and remove the ice, or fog remove from your, at the time of rainy season, if you want to remove the raindrop, then you can remove with help of the generative adversarial network. Then the next application, 3D model, means this time I'm working on 2D related things. My result in form of 3D. This thing is also possible with help of generative adversarial network. Then adversarial attack means everywhere. Or then a deepfake means mimicking your face. This is also possible using generative adversarial network. Then one more is related to your graph generation, graph related things is. This is also possible with help of generative adversarial network. Sentimental analysis, knowledge graph base. This is also your, then LSTM and recurrent base encoder decoder, you can design it and then design the generative adversarial network. So LSTM, recurrent, this also combined with generator and discriminator. Any question?
There is some question in chat box also.
Is there any specific website for game? Google is the best one, or I'll share the one. You go for Alat Kumar video, then YouTube have a lot of courses is available. On one where you not get the anything in related to generative adversarial network. This is very difficult to get the lot of blogs is available, like one Jane Jew is available. You can search all the model. All the model is. So all model they were explained is very proper way. This is result. This one the proper result. You never be assume this one the real or synthetic results. This all have a adversarial autoencoder, binary equilibrium, bicycle, lot of variant is available. Approximation 200 variant available in market. You can take the fork the GitHub code and try to develop this code on according to your application. This is the main thing. This one is a imprinting related concept, face imprinting related concept. The cycle gyan is very powerful. Style gyan 2, disco gyan. There's a lot of this one is text to image generation, sketch to image generation, sketch to image to video generation. This is also based on this DR GAN. Lot of model is available. This is not possible. I can explain all this model. I'm not familiar most of model, but how you can use this is depend on your work. Least square GAN. This is all MNUT multi pix to pix GAN. Aerial base. This all model is explained. You search on Google, you find a lot of resources on Google. Star GAN. This is the you never face. This is a generated image or this is the real images. Super resolution, those who working on super resolution, how to this one is images unit. This all have a Washington. This is the extended version of generative adversarial network, Washington GAN, and Washington GAN is not use the Kale divergence loss. This one use the earth mover distance. This one have available. Lot of variant is available. Can we stop or?
Sir, I request all the participants, if they have any query, please ask to sir.
If you start your research, please go start with generative adversarial network because CNN is saturated.
Sir, one question is there.
Yeah, ma'am, Keras and PyTorch is good. If you're working on generative adversarial network, my sincere suggestion, you must be familiar with all the frameworks because someone develop on PyTorch, someone develop on Keras, some develop on TensorFlow. You must be go for one thing is my suggestion, go for the PyTorch. E.g. compare than a TensorFlow. But you must be familiar with all the frameworks. This is research related thing. Research related things, you have to familiar all the frameworks. PyTorch is widely used in generative adversarial network, or very easy compared than a TensorFlow.
Okay. So thank you so much, Praveen sir. It was really a great session. You have explored a very new dimensions to all the participants, that how they can work with autoencoders, how they can work with GAN, and what is the process, how a beginner can start research into this particular topic. And definitely you have shown that how to do this into this practically. You have also shown the whole thing. So thank you very much, Praveen sir, for accepting our invitation to become an expert for this session.
Thank you for ma'am inviting and then inviting to me to take these sessions, because research take time. Keep patience and doing consistency work is the key to success in research. Or then read the paper. Okay,
Thank
ma'am.
you, sir.
Thank you for organizing this workshop, nice workshop. Okay.
Thanks a lot, Praveen sir.
Okay, ma'am.
I would like you to please stop your presenting your screen.
Okay, ma'am.
Yes. Yes. So this is the last day of this short-term training program, which is a 6-day AQIS and AICTE approved short-term training program on image processing and its applications. So we have started this STTP on 7th of September, and this is the second STTP. The first was earlier completed in August, and this is the second short-term training program on the same theme, image processing and its application. And we have successfully completed this short-term training program, which was started on 7th of September. And with the inaugural address of Dr. Deepak Garg from Bennett University. And then we have taken various sessions on image pre-processing and the machine learning, how to apply convolutional neural network, RNN, LSTM, image segmentation, and even we have learned that how to do this moving object detection. So this was the whole content for the this short-term training program. Now, I would like to invite our coordinator for the this valedictory session. Dr. Praveen Gupta sir is present here right now, and I would also like to invite the head of the Department of Computer Engineering, Mr. Deepak Mode, to join the session for the valedictory session. Welcome, sir. Welcome, Praveen sir. Welcome, Deepak sir.
Yeah, good afternoon.
Good afternoon, ma'am.
So now I would like to ask all the participants. I would like to ask all the participants for the feedback. So yes, if any participants want to share any feedback, I request you all to please. If any participants want to give any feedback for the short-term training program, is this STTP was useful for them, or have they learned from this STTP? So it would be great to hear from participants now.
Yeah, good afternoon, Dr. Sailesh Iyer from Rai University.
Good afternoon, sir.
Yeah, ma'am, actually it was a very good, well-organized STTP as we expect from Poornima group, because I have attended this method, FDP come STTP. So I found it as usual, starting on time, well-organized. All the features that we require in a STTP or FDP we have received. And the material also was being sent the same day, so for the next day morning. It's a very good way of conducting the FDP. And all the speakers were very good. Thank you very much.
Thank you, sir. I request all the participants for the feedback, if they have any feedback regarding this short-term training program. Many of the participants have written into chat box also. So thank you, Syed Ibrahim Kaliba sir and Gajendra sir, Sonam ma'am. So the main emphasis in this STTP was to introduce the new dimensions of deep learning and the machine learning, so that we as the faculty member learn a lot from these topics. Thank you, ma'am. I would like to invite all other participants also, if they want to contribute in this feedback session to improve the future FDPs. It would be a great contribution from all the participants if they want to give any feedback. Thank you, sir. Participants can unmute themselves and they can give the feedback. Thank you, sir. Thank you, Kavita S. ma'am, Sai Kumar Tara sir, Chula Maharana ma'am, Shrikala KK ma'am, and all the participants. I would like to say the STTP cannot be successful with the cooperation and support from all the participants. Now, I would like to invite Mr. Deepak Mode sir, Head of the Department of the Computer Engineering.
Thank you, Pooja ma'am. So it has been indeed a good sessions, technical sessions in this FTP. The FTP started from Monday, and now we are in the 6th day of FTP, that is Saturday. We have conducted 18 technical sessions during this period. We planned in organized way, like we will start with the image processing, then we'll move to machine learning, and eventually we will turn to deep learning. We also requested few researchers to contribute to actually elaborate their contribution, their research contribution, so that we can get fair idea about what is the new dimension in deep learning where research can take place. So it was a very good experience in this faculty development program. This was second in series. The first one was on image processing. Second one we have conducted on machine learning and deep learning. We are also planning to conduct one more FDP, that is a short-term training program again, which is sponsored by AICTE on the same series. There we are planning to make it more advanced, and there we are adding new dimensions like video analysis, image feature extractions from intermediate layers, as well as some topics of generative adversarial network. These topics we are adding in the next FDP now. So it has indeed good learning experience for all of us. And now I would request participants also to share their views, and so that we can get idea about what could be the new dimension in these FDPs for us in forthcoming days. So I would request you to unmute, and you can give us an idea, and you can tell the feedback of this FDP also. And thank you very much, Pooja Madam, for allowing me to speak in this FDP.
Thank you, sir, for supervising us and motivating us always to plan such short-term training program for the better planning and execution. You always support us. Now, I would like to invite Dr. Praveen Gupta, sir, for the vote of thanks and the coordinator of the short-term training program. Sir, please.
Yes. Good afternoon to everybody. I am audible. Hello.
Yes, sir, you are audible.
I am Dr. Praveen Gupta, coordinator for this workshop, STTP program. I would like to thank all the participants for their enthusiastic participation and timely joining of all the sessions, your active participation in the all the technical sessions, and maintain the very nice decorum in the sessions. I would like to thank also our management team, our chairman sir, our director sir, and all the team involved for this successful conduction of this STTP program. I would like to thank also the AICTE for providing us the opportunity for conducting this type of STTP program. In addition to it, I thanks all the participants who have joined it, and I expect in the future, in this series, we are also organizing a third STTP program very soon, and I expect all the participants to join that STTP program also, and encourage your colleagues and your research scholars so that they also join us and motivate us also. So, and in addition to it, I would expect you provide us, suggest us some new topics, new areas. You can provide through the textbooks also, in the text message, so that we can improve some sessions on the topics also, new research areas, new research topics. What is your expectations? So that we try to incorporate that sessions also in the next STTP program. Once again, thank you for joining the STTP program, and I expect you will also join in the next coming sessions also. We will meet you again very soon. Thank you very much for joining the program. Over to Pooja madam.
Thank you, Dr. Praveen Gupta, sir. Now, I would like to ask all the participants to please fill the quiz and feedback, and I requested you to all attempt this quiz and the feedback link, and the minimum requirement for the certificate is we expect the participant who has got 60% attendance at least, and the same as 60% marks in the quiz. So those are the short. Yes, I have copied the link over here. Are eligible for the certificate. So we will be processing certificate and this attendance in next week, and soon you will get your certificate and the the attendance also. So the quiz and feedback link I have posted into chat box. Kindly check it.